Alright, section 4.3, we're going to be going over greatest common divisor and least common multiple. This first one we have 8 parts. We're going to find the greatest common divisor, least common multiple for parts A, B, C, and D. I'm going to show you the method that they recommend you start out with teaching, and then later on I'll show you how to do it with primes. Okay, so with part A, we have the numbers 45 and 75. We want to find the greatest common divisor first. So we will list everything that multiplies to give us 45. That would be 1 and 45, 3 and 15, and then 5 times 9. Okay, I want us to list that out, and then with 75 we'll do the same thing. 1 and 75, 3 and 25, 5 and 15, 15, and I don't think we're going to get anything else. 6, 7, 8, no. Okay, so greatest common divisor, GCD, is going to be the greatest thing out of the list that divides them, that they both have. So they both have 1, they both have 3, they both have 5, they both have 15. 15 is the biggest that will divide both these numbers. So 15 will be our GCD. And then the least common multiple of 45 and 75. What we're going to do is actually multiply 45 times 1 times 2 times 3, so forth and so on. Same thing with 75, and find out which one, the smallest number, the first thing that we get to that they both have. So 45, 90, we'll multiply times 2, and then 135, and then 180, and then 225, and then 75, we'll do 75 times 1 is 75 times 2 is 150 times 3 is 225. Okay, and that is the first number, 225, that they have in common. So the smallest one when we do least common multiple, and we want the biggest number that they have in common when we do greatest common divisor. Now we're going to do 45 and 36. So what are they, the multiples, the factors? We just did this one, so 1 and 45, 3, 5, 9, 15, 36 will give us 1, 2, 3, 4, 6, 8, 18. Nope. I'm going to start on the inside. So 2 and 18, 3 and 12, 4 and 9. So that's what should be next. 9. And then 3 and 12, 2 and 18, and 1 and 36. Okay. Biggest number they have in common is 9. So greatest common divisor will be 9. And then if we multiply these out, 45, 90, 135, 180, 225, and we'll keep going if we need more. 36, 72, 108, 144, and then 180. Okay, so they both have 180 in common. Okay, so C, we have 3 numbers, and as you get more numbers and the numbers get bigger, it could take more time. So this time I'm going to show you how to do it with prime numbers. Okay, so as the students get more comfortable with multiplication facts, when you're teaching them, prime numbers is going to be the way to go. So we're going to find greatest common divisor and least common multiple by finding primes. Okay, so we're going to do 8, 24, and 64. 8 can be broken down into 2 times 4, and then the 4 can be broken down into 2 times 2. So we're going to take all these stems. 8 can be rewritten as 2 cubed. 24, we can write 2 and 12. 12, we can write 2 and 6. And 6 we can break down to 2 and 3. Okay, so we have 3 2s and 1 3 on the ends of our stems. So we have 2 to the 3rd power, so 3 2s times a 3. And that is going to represent the prime factors of 24. And then with 64, we have, let's just say 8 and 8. Okay. And we know that 8 is 3 2s, so we'll just have 2 4, 2 2. And then we'll do the same thing with this 8, 2 4, 2 2. So we have 1 2 3 4 5 6 2s on the ends of our stem. So we have 2 to the 6th power. Okay, so these are our prime factorizations of each of those numbers. Now if I want to find the greatest common divisor, GCD, we have to look at what they have in common. Okay, so they all have a 2 in common. And then, although it says greatest, we're taking the smallest exponent. The reason being is, just imagine all 3 of these are people who are going to pay the same amount or split a bill, and they all want to give the same amount. Well, what's the most that everybody can give? He can give 6, but he can't give 6 2s because he only has 3. Same thing for this guy. So we have to take the smallest. When you do greatest common divisor and you're doing prime factors, you're going to take the smallest exponent in every number that they have in common. So they only have 2 in common, and they all have 3 that they could give up. So 2 to the 3rd, which is 8, is going to be our greatest common divisor. And then least common multiple. Let's go ahead and do that one here. LCM, because that's going to be next. When you do the least common multiple, you're going to list everything that appears. So all the base numbers, the big numbers, so 2 and 3. That's the only thing that appears, 2 and 3. And then we're going to take the largest exponent. It says least common multiple, we're taking the largest exponent. So out of the 2's, the largest exponent is a 6. And then out of the 3's, there's only 1 3. So the least common multiple is going to be 2 to the 6 times 3. 2 to the 6 is 64. And if we do 64 times 3 is going to give us 192. Okay, so you can just multiply that out with technology if you need, but we get our least common multiple and greatest common factor using prime factors and following those steps. So greatest common divisor 8, least common multiple 192. And the reason I did this this way, it would take some time multiplying 8 out until we got to 192. So the more numbers you have, you'll end up doing bigger and it's more tedious. So this is a method that you want to ultimately get your students to be able to do. Alright, and then with 7 and 4, okay, so the factors of 7 are 1 and 7. Factors of 4 are 1, 2, and 4. They only have 1 in common. And then as far as prime factors goes, 7 is prime. 4 we can break down to 2 times 2. So we're looking at 2 squared. So when we do LCM, remember we need all the different factors that appear. So 7, and I need 2, and they only have 1 of each. Okay, so with 2's, this is the only exponent to look at. 7 doesn't have 1. So 7 times 4 will give us 28. So greatest common divisor is 1, and your least common multiple is going to be 28.